Hello. Sorry about the technical issues. So, my name's Martin Abbott, so as you can see. Just a very small bit about me, although you can hear from my accent probably if you pick up on accents that I sound British. I don't want to be associated with that place anymore. No, thank you, Brexit. I'm actually Australian, hence the shirt. I've been in Australia for 8 years. I'm Microsoft MVP for Azure for the last 5 years. I'm also a Microsoft Regional Director. That doesn't mean I work for Microsoft. It's just a different type of MVP, I suppose. I'm also one of the admin team for Global Azure Bootcamp, so if you do have any questions about that, please come and see me. Global Integration Bootcamp as well, along with Elder at the front here. Do we have any? Oh, Glenn, you're on the same, aren't you? Oh, who knows? You should be. I also help run something called Integration Down Under. So if you're an integration person, you may have heard of Integration Mondays. That's something that runs by a couple of guys in the UK. We thought that because we're in a really, really awkward time zone for that, we'd run a kind of equivalent down in Australia and New Zealand, so I run that as well. I also run the Perth Azure User Group. I've written that book that just says there, and if you're anything to do with, if you know anything about Aussie rules football, anybody Aussie rules football? No, it's a fairly arcane form of football, but I'm a Fremantle Dockers fan, so I'm a season ticket holder. Go free, I go.
Who's the young guy in the middle?
I think he was in ZZ Top or something. I'm not sure. Yeah, he has got a Finnish beard. So that's about me. So we've had one talk from Glenn about IoT as a general technology. I'm going to touch on some of that a little bit, but I thought I'd talk more broadly about the edge, because that's kind of the new battlefield in terms of IoT. So the shift to the edge. So where did we get to in terms of IoT, and why are we where we are? So I think if you look at IoT and what it is and everything like that, it's been around forever. If you look at mine sites, manufacturing, there's always been a degree of telemetry from one place to another place, and data gathering and so on and so forth, and decision making, decision support. I think what the cloud has enabled as a result of that is being able to take all that data, move it into the cloud, have large-scale compute. Unlimited compute obviously doesn't physically exist, but it's unlimited in terms of your needs. And being able to process that at scale. So that's part of that enablement around IoT in a more broader sense. IoT generally, if you think about sensors, you can pick up a temperature sensor for a few cents nowadays. So that enablement has been accelerated as a result of the cost of sensors as well. The edge is kind of, as I say, the new battlefield. So as technology has moved forwards and those edge devices, the ability to run computing on smaller and smaller devices and getting value that is closer to where the data is gathered, has pushed some of that technology out to the edge. And of course, everybody talks about AI. Do they mean AI or do they mean machine learning? Who really knows? But essentially that ability to go from what is gathering data, getting some insights, maybe doing decision support, to full automation, so production automation, processing automation. I do a lot of work in mining, don't hold that against me, and having basically essentially an intelligent mine. So that is kind of like the next step on that journey, I guess. But it's not without its challenges, right? So IoT can be a fairly challenging environment to work in, I think it's fair to say. So a good example, we see high volume of data for data collection sources. So in a typical mining circuit, you'll have maybe technical issues. So you'll have 150,000 sensors reporting every second. And they'll all be dumped into an operational historian where people will do lots and lots of reporting. There'll be some decision support. That's a lot of data to process and then move up to the cloud. So there's certainly issues around that sort of thing. The high cost of transporting that data to the cloud. If you want to do that at scale, then you can't really just start moving terabytes of data across the wire very easily. And limits to real-time insights, that's probably less of an issue nowadays. You can throw a stick at Azure and hit 25 different data services, all of which will give you a fairly good story around some real-time insights. But certainly there's a skills barrier there. So, anybody in the room a data scientist? Oh, there's one at the back. So I didn't write the Python code that's coming up later on. I just want to be very clear on that. That whole idea around data science, it's the new thing that everybody wants to get into. Not new anymore, of course, but so the ability to deliver those real-time insights is certainly one of the challenges. When you go out to the edge, that traditional kind of edge processing, embedded code, very small devices, that's a very, very specific skill set. In fact, there used to be an MVP category for embedded devices because it was so specialized. Custom code for everything. So you will always find that from a competitive perspective, somebody will create a device and they'll use their own protocol and their own messaging process because it gives them an advantage. So that there's no real standardization. And then from a manual setup and integration perspective, an ability to go, okay, well, I've got a fleet of vehicles, for instance, that all have telematics coming up to the cloud. How do I onboard a new vehicle when I may have a global fleet? So that sort of thing. So how do you overcome these barriers in a meaningful way? And the other thing I like to talk about when I talk about IoT is what I call, I don't call it, loads of people call this, the IoT value chain, right? So IoT, Internet of Things, everybody thinks about the things, but you don't have an IoT solution without something that does pretty much all of these things, right? So you have things, you have connectivity, that might be Wi-Fi or 4G, even 5G nowadays. Data, so storage and engineering, so change data. Analytics, trying to get some insight out of it. And then some form of action. Now that action may be a report, that action may be some form of automation, right? The reason I mention this is because when you think about IoT in terms of the cloud, and you think about IoT on the edge, this still applies when you do stuff at the edge, right? So this whole chain just now applies at the edge rather than all the way through your processing pipeline. I'm going to do Zachary's trick here and have a bit of a drink. So, given some examples, I suppose, of IoT in the cloud and IoT on the edge, fairly typical one, remote monitoring and management and predictive maintenance. So there's a solution that has been built actually in Azure that's used by Rolls-Royce. So when they fly long-haul flights, a typical Rolls-Royce engine would generate about 4 terabytes. Aha. Have we got a battery problem? There you go. Cheers. Well, I'll leave that to your imagination. So, again, remote monitoring, predictive maintenance, it's a fairly typical use case where you'll uplift lots and lots of data, you'll do some analytics, and you'll try and get some idea of when something may fail. So, like I say, aircraft engines is a great example of that. You know, hopefully you don't get an alert whilst the plane's in the air. But general fleet management is a great example of where you might use this sort of thing, remote monitoring. So you want to know where things are. Maybe they're geo-fenced. You're not allowed to enter a certain area after a certain period of time. So all that sort of thing. Merging data. So again, that's just lots and lots of data, just bringing it up into the cloud and merging that data to find some kind of insight. And of course, using the AI tools that are available through Databricks and various other services out in Azure as they are. What about the edge? So on the edge, the key thing really, and the thing that I'm going to be talking about mostly today is the top one, so tight control loops. So you can imagine that if you've got a gas plant, I live in Western Australia, in Perth, in the northern part of Western Australia, we have a couple of really huge gas fields. If you've got gas coming in from the field, and it's coming into a valve, or it's coming through a pipe, and it's going into a huge processing plant which has cost $10 billion to build, if there's some kind of overpressure, what you don't want to do is rely on that data going up to the cloud, being processed, pushed back down so as you can close the valve so as you don't kill the 150 people that are working in your plant. What you want is to make that decision at the edge, where you need to make that decision, so that you don't run that risk. Another example of that is, and actually I was due to give a talk last year here. That talk was called Bilby or Not Bilby. So a bilby is a very small indigenous animal in Australia. It's critically endangered. It lives in areas where we're subject to very, very high levels of feral cats. They predate on the bilbies and the things they eat. So they've got camera traps. Right? Those camera traps capture an image, capture an image. If it captures a cat, then the solution which we were building at the time would be an alert, but we were also going to have actual traps. So when a feral cat would go into the trap to get food, the trap would close. If a bilby went in, the trap would close, and we'd open it back up again so the bilby could get back out. So there's an example there. Protocol translation and data normalization. So if you think about manufacturing sites, they tend to be very old and dusty. A lot of the messaging and the telemetry that comes from the devices speaks a variety of different types of languages, Modbus and so on and so forth. There's a standard called OPC UA, which we've got a partnership with a company called Omron. They have something that you can retrofit directly into a brownfield site. It understands all the inbound protocols from typical manufacturing equipment, and it outputs a perfectly standardized message out to Azure. So again, it's just a box. You literally bolt it in and put the feeds in. So that protocol translation. Privacy of data and protection of IP, of course, that if you've got privacy issues, then you don't necessarily want to be pushing that across the wire. You may want to keep that local to where you're processing it. But the key thing about IoT Edge, and that's the key part of Azure IoT Edge that I'm talking about, is that when it comes to writing this stuff, you want to make sure that if you've got that knowledge where you're already building solutions in the cloud, that you can reapply that knowledge without having to learn a bunch of new things when you're doing that at the edge as well. So fairly key. How we do for time? So these are the typical sort of scenario of people you get it's not just Edge, it's actually anywhere in terms of IoT. So you'll have a developer, they want to be using their tools that they understand. So that would be things like VS Code in this particular case. And they'll have operators, the people who are responsible for lifecycle management of those devices. They want a common place where they can go and manage not just the stuff that they have in IoT Hub, which we'll talk about, but also the stuff that's at the edge. So, enter Azure IoT Edge, which allegedly does all these things. So the key things I think here from a takeaway perspective is obviously move cloud and custom workloads to the edge. We've already talked about that. Securely, there's a product called Azure Sphere, which has a very, and I think, Glenn, you mentioned yesterday about the 7 properties of secure devices, right? So Azure Sphere is one of those. So that's a key way of making sure that your devices can't be compromised, because if you compromise a device, obviously you can send poison data and cause all manner of problems. Seamless deployment of AI and advanced analytics. I'd actually push that further and say seamless deployment of anything, and we'll talk about some of that. From that operational perspective, an ability to just onboard new devices in a common way, so from the cloud or elsewhere. You can use tools as well, of course. Compatible with, this is a marketing slide, you can tell, can't you? Compatible with popular operating systems. What does that mean? It means Linux and Windows, right? Again, that key one, the code symmetry, it's very important. Secure solution, so then again, that's that Sphere side of things. But the last one, which actually I added, is that fully disconnected operation. So when you want something that has that closed control loop, you may never want that thing to be accessible anywhere else. A great example of that kind of scenario is SCADA. So anybody, again, who's worked in large sort of sites will have heard of IT and OT, operational technology. There's an air gap between that typically, and that is because you don't want to compromise those systems, because if you compromise those systems, you can kill a bunch of people. And obviously gain IP and so on and so forth. So being able to disconnect in those kind of scenarios is vitally important for customers to even think about using some of these technologies. And in this particular case, the first time a device connects, it has to go up to Azure because it has to get some security information. But once that's done, it's free to do what it wants. Or what you tell it to do. So, the other things that Azure IoT Edge give you. So, we'll go on to how you deliver this in a second. But typical things here, so there's an AI toolkit for IoT. Machine learning, so you can build models in the cloud, expose them as a container, push them down to a device. Stream analytics. So stream analytics, I think we mentioned that yesterday. bunch of inputs, bunch of outputs. You can actually take those queries and just push them straight out to your edge devices. SQL Database Edge, that's actually in private preview right now, so you've got a great use case, you can use it. So it's basically a low-level SQL server that you can run on your edge device. Supports time windowing to a degree. Doesn't fully support time series analysis. Azure Functions, obviously that runs in its own runtime anyway, that can be containerized, so that can go out. Event Grid was mentioned by Sam yesterday. I probably agree with Sam on some of the things you're saying about why, some of the whys of that, but so my own internal jury's out on that one. Blob Storage, another quite new one. So the runtime actually supports store and forward anyway, but this is just another feature for it. And of course your own code. So there's SDKs for all of these things, right? So you can write your own modules and move forwards. So that's not displaying, so that's good. Okay. There we are. So we mentioned the cloud to edge symmetry, programming tools, the tools that you know, but also those languages. So again, that comes back to that reusing your skills, an ability to take the skills you already have and the people you already have and just reassign them to other things. And we've talked about some of that stuff already. So the minimizing downtime is an interesting one. Like I say, we do a lot of work for mining. If a mining circuit could have, like I say, 100,000 tags. That's a big problem to try and solve. If you look at one area of that, and one of the ones we did recently in the company that I work for, is a primary crusher. So that's something where rock falls in, it gets crushed, and moves on further down the circuit for processing. If that gets bogged, you can be millions of dollars an hour lost revenue. Right? So making sure that first thing that's in that circuit doesn't get bogged can really, really minimize your downtime, obviously, and have huge financial benefit. Now, will this move forward this time? Yes, fantastic. So at the center of Azure IoT Edge is the IoT Edge runtime. It does these things. I'm going to talk a bit more about these in a future slide. But essentially, it's the thing that allows you to publish modules to it, keeps them running, and then allows the messaging to go between them. So what is a module? So you saw that I mentioned about Azure SQL Database, Azure Event Grid, Azure Functions. They're modules, okay? So they are essentially containerized pieces of compute that you store somewhere, that you set to push down to your device, and that you then configure messaging to go in and out of. So think of it so think of the runtime as a bus, and think of these modules as components that send and publish messages and subscribe to messages off of that bus, essentially. So a module instance is an instance of that module on one of the devices. The identity is the pieces of information that say about how that module communicates, essentially. The twin is, so does anybody just show of hands, who's used IoT Hub? Okay, so you're familiar with the concept of the device twin. So for people who have got knowledge of that, so essentially it's a way of allowing disconnectedness and enrichment of information for a device. So each module inside your IoT Edge device has its own twin. So you can provide information to that instance, that running instance. And there's obviously a bunch of SDKs as there is for all these things because Microsoft's pretty good at providing that sort of stuff. So I'm just going to build that slide out. So in this particular case, you can see we've got a protocol ingestion. So call that protocol translation. So there's something outside that doesn't understand how to talk to IoT Hub. So you build this module that translates that. You essentially publish that message into the IoT Edge runtime, and then you have something else that reads that data and pushes it back out again. And then the runtime itself pushes that data up to IoT Hub. Because IoT Hub is still the endpoint for all these things, right? The runtime itself has these two modules. This is why I didn't talk too long on the other slide. So there's the Edge Hub. So think of the Edge Hub as essentially a containerized version of IoT Hub running on the Edge device to allow that communication. So it does the handshake, the security handshake. It's allows the communication backwards and forwards with IoT Hub. And then an agent, so they're pretty well named. Agents do stuff like this typically. So keeps things running. If they fail, starts them back up again, and then reports that information back up to IoT Hub. Still, okay, I didn't move that build. But of course, when you have that bus and you have these modules, you need to understand how to get messages from one to the other, right? So that's routing in this case. So I have to say routing because I'm not allowed to say it a different way in Australia. So I've grown used to saying that. So there you are. So when you create these routes, so if you can see the thing on the, what's that, as you're looking at right-hand side, is the runtime. Then you've got the modules. Modules have inputs and outputs. So if I want to go from module 1, send a message out, and into module 2, which is with its inputs. So you can see that the source is modules, module ID, outputs to send a message out. You can have conditions, fairly simple conditions. They're not complex, obviously. So source temperature or alert. $upstream is a very special reserved output, and that basically says if I send stuff to $upstream, what I'm doing is I'm sending that to IoT Hub. And the runtime deals with that communication. If you're sending it to another module, then you use brokered endpoint, and you can see what that says. And we're going to go through the demo and create one of these anyway. So you can see at the bottom there, we're saying everything, so star is everything. Every message that comes out of module 1, where the sensor type is temperature, I'm going to send into the input of module 2. So that's that flow you can see there. So how do you create these things? So I'm going to use a virtual machine. I don't have a device. I can explain the reasons why to anybody who wants to know. But so essentially what you do is, this is using Ubuntu. So you register a new package repository, get a key from Microsoft, do an update. Of course, we always do updates. Install the Moby engine. That's not the guy who plays keyboards and everything like that. That's a different Moby. This is a lightweight Docker container engine called Moby. So you install that engine and the CLI, the command line interface, and then you install the IoT Edge runtime. So all of those steps, obviously you can build into a script, and it's really, really simple. It does take a few minutes to install, so I won't be going through that in terms of an install. The next thing you do, so if you're using a connection string, please don't use connection strings in production. Use certificates. But if you're using it, so I'm going to use connection strings, it's easy. Then you update this YAML file, you stop and start the IoT Edge runtime, and all of a sudden you've now got an IoT Edge device talking to the cloud. So what's that? About 6 lines. And then you've got a device talking to the cloud. And in the runtime, there's a bunch of great tools that allow you to do various things. I'll actually go through most of these, so I won't talk through them too much in these types, because we are running a little bit long. IoT Edge can also act as a gateway. So if you've got a bunch of devices that you want to, or that can understand talking to IoT Hub, then you have a gateway in between, and IoT and the Edge runtime will multiplex those messages out. So it'll be one connection, but it'll multiplex those messages out. Protocol translations we've mentioned. So again, just so you'll have the Edge device, single connection, single device in the cloud, which means that your devices that are sending data in, you're probably going to need to enrich the inbound data with the information from that device, so as you know what device that thing came from. So that's that protocol translation pattern. And the last one is identity translation. So this is one I've actually used in Anger. So the things on the left-hand side, as you're looking, don't understand how to talk to IoT Hub, right? Don't hold their own identities. But they hold an identity that the runtime understands. So the runtime can then translate that identity to an IoT Hub identity and send that data on its behalf, essentially. Right, well, I think I want to get to the demo, really, so we'll just build this out very quickly. Oops, showing my wares. So this is a typical process. You'll create the device, you'll select what node you want to deploy things to, you'll define the modules, these containers, you define the routes between those containers in the module twin, you'll push that out, and you can see here that you'll have a container registry in the cloud for your own stuff, or that might be a published registry that you have access to. Those then get pushed down to the device. Happy days. You're then up and running, and you've got your process. A few other things just to round this out. There is an Azure DevOps pipeline components for this as well. So you can see here, build module images, push module images. So you can actually make this part of your standard CI/CD process. There's a marketplace where you can go and either grab some modules that are already there or buy modules off of other organizations. And Codit actually themselves have a bunch of modules up there that you can use. And the last one, this was announced at Ignite. It already existed. It was called Databox Edge previously, but they put the Databox Edge into the stack, Azure Stack. Sorry, Rick. If you want to know anything about Azure Stack, by the way, then please do talk to this man here with the long hair. Because it's one of his favorite products. And he waxes lyrical, he really does. But the key point there really with this is that they're more capable devices. So they're not just little small things. So this one on the left-hand side, as you're going to there, is a 1U blade, which you can put in your data center or somewhere. It's got an FPGA in it. That's the current one. There's a GPU one coming. The one on the right is a ruggedized version of that. So think about ships, trucks, all those sorts of things, where you have a much more harsh environment and need something. There is actually also a very, very cool, and at Ignite in the technical keynote, they showed this, a very, very cool backpack-based version of that ruggedized one. So imagine the scenario. The person was on stage. The person behind him had this small portable one and is beavering away running some reports. He detached it, so it's now running wireless. And then he went like that and dropped it on the floor. And this person's still working, right? So imagine being able to do that in, say, a really, really harsh environment like mine sites where you may have to go underground, plug into things, lots of dust, lots of sound, lots of noise, just general problems with any kind of radio telemetry anyway, right? So that's coming. I couldn't tell you when because I don't know, but it is coming. So that I think is probably going to open up a lot more use cases because they are very, very capable devices. Which, hey, brings me to the demo. Fantastic. So I thought what I would do is I'd go through the process of creating one of these, right? So here we have a VM. So this is the Linux VM. I've installed the runtime already on here. So what I'm going to do is I'm going to go and restart that, if I can type. Doesn't take long. And then one of those commands that I mentioned before. So there you go. So this doesn't have anything on it. So at the moment, it's just got the Edge agent. So there's no modules or anything on here other than the runtime. So what does this look like in the cloud? So if we go up to IoT Hub here, and I've got a fallback position in case things go wrong, because we have had a fair number of demo gods being invoking the ire of demo gods in the time that we've been here. Excuse me. This is fizzy water. That was unexpected. So I've got two devices. So one's offline because the other one I haven't started. So the VM's running, but I haven't started the runtime on it. And the other one is kind of reporting. So if we look at that one. Oh, screen resolution, fantastic. We'll see that the agent is installed and the hub is installed, because that's part of the runtime, right? So the hub doesn't report because it's not doing anything at the moment, right? So what we can do is we can go in here and do set modules. And I can choose to add a module. Come on, there we are. So you can see here an IoT Edge module, a Marketplace module, or a Stream Analytics module. If I go to Marketplace, it rather helpfully opens it up, and I can just grab that and set some configuration, and then when I've finished the routing, that will be just pushed down to the device. Really, really simple, okay? Oh, and look, Nebulous Matrix, code it. So there you are, a Nebulous file receiver, code it. So Sam here is the CTO of Code It, so if you want to know about those modules, I'm sure he'd be happy to talk to you. So that's one way of doing it, but I like doing things a bit more hairy than that. So I'm going to Visual Studio Code because nothing says fear more than live coding. So there's a bunch of great tooling that's already built into Visual Studio. Well, you have to install it as one of the extensions. So it's the the IoT Tools extension. Once you've installed that, you get some cool things around the IoT solutions and everything else. So I'm just going to go ahead and create a brand new solution. Yeah, we're not going to do it there. We'll do it there. That's fine. We'll call this fan control. It'll become clear as to why I'm calling it that eventually. I'm going to have a C# module. I'm like Alan here. It's my language of choice. I know just about enough Python to be extremely dangerous. So this is asking me where I want to push this module when I've built it. So I can run it locally. And there is a debug experience locally, although yesterday that wasn't working on my machine. But what I'm going to do is I'm going to grab this here because I've got a container registry up in Azure already where I'm going to push this to. So I'm just going to get rid of that. And off it goes, and it starts creating it. So the one thing that it doesn't do is log me in to that cloud-based container registry. So whilst it's thinking about that, yeah, there you go, wait. Oh, that's unexpected. Invalid input switch. So this is where I now worry that they've pushed a new builder to Visual Studio Code. So I said that about the demo guys, didn't I? I shouldn't have said that. But let me just log in anyway. So Docker login -u IglooConf ACR. Right. Azure CR. I should have just copied that, shouldn't I? Right, it's asking me for login. So I'll just go here and grab the password. Do I? There. Oh yeah, well spotted. Oh, go away. Right, so hang on. Backspace. Login succeeded. So we'll just try that that create again. I'm not quite sure why that didn't work. Let's get rid of the folder first because it will have created the folder because that's what it does. So try that again. That folder there. Yep. You can see I've got a backup of the file anyway, but I just want to make sure that we get this going. Control solution. It's going to be a C# module. Fan control module. And we're going to change that. That's not the wrong one. Oops. So if this doesn't work, we'll move on to the next piece, right? But grab that. Slash fan control. Come on, you can do it. Right, so there we are, fantastic. I probably had a typo in that as well. So what you can see here is that so we'll ignore that message over there in the corner. What it's done is created a new module. We've got a program file, and it's now nagging me. And this is a really, really simple piece of code. So anybody who's done anything with IoT, some of this will look eerily familiar. So we have a request handler to deal with inbound messages. You can see this here. And then we have, where are we? Pipe message and outbound. So you can see there it says send event to output 1. So you can remember the routing, inputs and outputs. So that's how we start wiring this up. Really, really simple code. Right? Now the code can also deal with things like direct methods. So anybody, again, who's done IoT hub stuff will know that you can send a message when it's connected directly to the device and get a response. You can also send messages to the device. You can also do module twin updates. So all of those things is symmetrical to the sort of stuff you can do in a typical IoT hub solution. In this particular case, what we can see is hopefully, is that is that too big? No, exactly, I can't. It's bringing a message in, we're creating a client, I'm grabbing the message here, message string, I'm adding any properties that there are, and I'm just sending it back out. So this is kind of acting just like a proxy in a way, right? So that's fairly important. If we go to the deployment template, which is the thing that defines how these modules are set up and how they talk to each other, we can see there's a pretty simple piece of JSON here. There's the edge agent, there's the edge hub. Here's our fan control module that I've just created. And when you create a brand new solution, it brings in this simulated temperature sensor module as well. Okay, so, and then down the bottom here, we've got the routing. So what this is saying is, I'm going to get messages from my fan control, from my sensor, temperature sensor. As you can see, the temperature output, the second line. I'm going to put that into fan control, and then everything from fan control, I'm just going to push up to IoT Hub. So essentially, all this is doing is going, okay, whatever message I send out, I'm going to push straight up to IoT Hub. It's not really doing very much. So because we are running a little bit shorter on time, what I'll do is I'll move on to the solution. So if we go back up to the cloud, what I also have here is in Azure Notebooks, come on, a Jupyter Notebook that does a bunch of things. I'm always glad to see that rather than the unexpected error message that I've been getting for the last 3 days. So that's always helpful. So I set a bunch of stuff. I push a model or create a model, and I push it out to Docker, right? So I'm going to start running through this just so as we can get moving. Yeah, that's fine. Does that run? Yeah. Just setting some variables. I need to log in because obviously I'm going to be pushing stuff to Azure, so I need to log in. So we'll just do that very quickly. Very quickly. Oh, there, it's there, right, good. So we'll just copy that. This was super fast yesterday. That's me, fantastic. Right, so we're there. So let's just come back in a second. And essentially what we're going to do, so we're back. Essentially what we're going to do is we're just going to set another variable, check that we're running the right version, which we are, fingers crossed. We'll let that return. There we are. But again, from anomaly detect, this is doing anomaly detection, right? So essentially, if you had that data coming up, you could build your model in the cloud. So this is using Jupyter Notebooks, but you can build that anywhere. But there's a fairly nice experience if you go through Jupyter Notebooks, Azure Notebooks. Then we're going to get that model, we're going to push it into Azure Machine Learning. We're going to publish the image based on that module, which is essentially just a web service that runs the model with inbound data. That will detect whether there's an anomaly in that data, and the outcome of that will push out a message, which will then process through the fan control module, right? So we'll just run through some of these things, just make sure it's all working. So I know I don't need to run that, so we'll go there. We'll load the data in once that's finished. There we are. So this just comes with this, this temperature data, and we'll just quickly look at that data. I shouldn't keep using the word quickly, because that's clearly screwing things up. So we can see here there's a bunch of information. Typically we've got machine temperature, an ambient temperature, and a pressure, and then we're making a decision as to whether it's an anomalous value or not. Right? So pretty standard stuff. So we are just going to run through a bit of things here, just so you can see what it's doing. Nothing too scary. Oops. The only thing that's scary is my ability to hit the right key. And then do that. All right. Yep, so we can see there that we've tested it and we got back some value. So we've done our model. We're now going to register that model with Azure Machine Learning. That doesn't take very long. And we don't need to do that. Actually, let me just check that, because I do need to know the version. Version 7, right? So the next thing here is what we're doing in terms of essentially our web service. So we're saying, okay, well, I'll go this way for a change. We're going to get some input. We're going to put that into a frame. We're going to test it against our model. And then whether we get a 1 or a 0 back determines on what message we send back out. If we get a 0, we're going to send back false. If we get a 1, we're going to send out true. So you can imagine that you're building this pipeline. You've got the simulated temperature sensor. It's sending data into this web service. The web service is scoring that data and going, this is an anomaly, this isn't an anomaly. We're then going to pass that information to another module, that fan control module, and then do something within that fan control module. So if you can imagine if this was a real scenario, that would maybe be wired up to a servo to turn on a fan or whatever. It doesn't really matter what it is. Overwriting, there we go. That's finished. Yep. Just need to set some information up in terms of how we build our Python environment on the Docker image. We're then going to create the Docker image. Now that takes a little while, so whilst it's doing that, we'll just go here and just run that so as we know what's happening. I thought I'd come and show you some of the other stuff here. So the IoT Edge runtime is fully open sourced. Right? So if you go to this GitHub repository, you can see in here we have the Edge agent, we have the Edge hub. So you can go in and tinker with this, grab it for your own purposes. It's under an MIT license, so you can grab it and reuse it. There's a bunch of Edge modules that they've written as well as a starting point. Not least of all the simulated temperature sensor module that we saw brought in. This is the marketplace for Azure IoT. So again, you saw some of that, but we can see that there's 20 modules in here at the moment. Bunch of good stuff in here. All manner of things as well. So Modbus is a particular mechanism, so that's a protocol mechanism. Security sensor. So you can run a security sensor module on your device and have it post information to Azure Security Center. So as you get that view of the security of your devices. A few other things in here as well, right? Redis Edge, so cache in your, so you can have a local cache on your device as well. And the other thing that I thought I'd go through is Microsoft has a certification program for devices. So if you want to use something that Microsoft have put their rubber stamp on as your Edge device, you can go to the device catalog. So you can see here, catalog.azuriotsolutions.com, and look for the Edge devices that have been certified. And there's a bunch of devices here that have been certified. So you can go and have a word with one of these organizations, and because nobody builds their own devices unless you've got a lot of time and a lot of money, because people already build that sort of stuff for you. So that's still running. So whilst it's doing that, we'll also come in here. We'll go back to here. So the other thing that you can do with Azure IoT Edge is deploy at scale. We saw that. So you can see at the top here, create deployment and create layered deployment. So a deployment is an entire solution. A layered deployment, as the name suggests, is parts of a solution that you can apply on top of each other. Right? So if you think about a deployment, think about it as in a template that you can then stamp on as many devices as you want. Right? So that's what you're doing. You're creating a deployment to stamp onto templates. How are we doing for time? 10 minutes. I think that should be enough. Right, so it's completed that. You can see here, there's one I ran earlier. So just run that again, and we can see I've just created a version 9. So that's good. I then won't, because I don't need to do this bit, because I know what the various settings are that I need to set in my deployment. So essentially what I've done is if we go back into here and we go to machine learning, so I've created that image, and that image is published to an Azure Container Registry in my subscription. So I now have access to this. I can make that part of my deployment, and I can push this directly down. And essentially all I have to do is I have to create the deployment. The Azure IoT Edge runtime deals with pulling those containers down for me, so I don't have to do that. So all of that is just part and parcel of the tooling. So we'll go back to here. I'm just going to copy a piece of code from here's one I made earlier. So I'll just go down here. This is where a mouse is sometimes handy. Oops. This is where a mouse is definitely handy. Let's do things the old-fashioned way. So what I'm doing here is, and it will be pretty obvious when I paste the code in, and I just need to fix up because that's not in the usings. System.collections.generic using soft.json. Right, good. So now we should see the red disappear. Right, so essentially, and I've not created the message. That's the other thing I haven't done. Right, so let me just grab that. So here we go. Right, so all the red's gone. So you can see here that what I'm doing is I'm grabbing the inbound message, because I haven't changed that code. Now, the strange thing about the message that comes out of the machine learning web services is it's actually a JSON array, and it's not an object, it's actually a string. So it's a wrapped object, essentially. So you have to do this little dance where you get the string out of the list, and then you just choose the first one in this particular case. So you can see I'm just choosing the first one to get my anomaly. You saw that it just had the word anomaly and true or false. So essentially all I'm doing is it an anomaly? Yes or no? If it's an anomaly, turn the fan on. Really simple, right? So the other thing that I need to do when I deploy these things is create the deployment template, because this is a new module that I've created, or I've created the machine learning module, so I need to include that. So what I'm going to do in terms of expediency is show the one I did earlier. So there we go, around here. Wrong one. Right, so here we go. Here's one I created earlier. Let's get rid of some of this real estate, shall we? So here we can see that I've got my system modules like I had before. I've got my fan control module. So that's just something that I've published to that particular location. I've got my simulated temperature sensor, and I've got my machine learning module. So from a routing perspective, what I'm doing is I'm going, okay, well from my sensor, I'm passing the data from my output, my temperature output, into the input of my machine learning module. So that's going to pass in a piece of JSON. I'm getting the data from my machine learning output and passing that into my fan control mechanism. That's going to publish whether it's true or false, essentially. And then I'm actually just taking my outputs and pushing those up to IoT Hub, right? So fairly straightforward. From a tooling perspective, all this is really, really simple. So if I just right-click on here, you can see that I can do all the things I need to do inside Visual Studio to get these deployments, these modules, published to Azure. So if I choose Build and Push IoT Edge Solution, it will create a Docker container, and it will push it up to the modules that I've written, and it will push that up to that ACR, so the container registry, so as I can then start using it. It will then also generate the the deployment templates, the actual deployments, because this is a template that you can see here, that's why it's got deployment.template on it. It will create the actual physical deployment that I need to push to Azure IoT Hub. So here is an example of one right here, right? So deployment. So I've done a bunch of replaces, so you can see that it's replaced my name and my password and the address. I've added the other one because this is the container registry for my machine learning environment. So it's done some replacements and it's created this. Just a word of warning, when you do push your container up, if you make a change, it will absolutely make that change and it will push the layers that have changed up, but you won't get that version down on your device until you change the version in here, because you have to tell the deployment that you're now using a new version. It doesn't know that automatically, auto-magically. So that's just a word to the wise. How do you do this? If I go down to my IoT Hub, I can choose create deployment for a single device. I can then choose that device, and it will create that deployment, push that JSON, because bear in mind at this point, all the modules are up in Azure IoT land, or in Azure, they're in the container registry or somebody else's container registry. So all I'm doing is I'm pushing this JSON up to IoT Hub, and any device, so the device that I've chosen for this particular case, and of course this could be a deployment, so this could work for a whole fleet of devices. Well, then you go, okay, well I know what I need to do. I need to push these modules down to that device, and it's pretty quick, right? So depending on the size of the module, of course, because it has to download it, but as soon as you make that change, you're going to start seeing those modules come back down. So here is my other, that's the wrong one. Here is my other device. So I'll just start, I'll just start IoT Edge on here. Restart IoT Edge. And if I do IoT Edge list on this one, you'll see that it's got the machine learning module, the temperature sensor. Don't worry about the fact that it says failed. It's just starting up, right? I'm not too concerned. Hopefully. Right, so they're all running. Okay, so you saw how quick that was. So imagine that I just restarted this and I hadn't got those modules back down. I would now be waiting for those modules to be pulled down. What I can also do is I can look at the logs of the individual modules. So if I look at the log of the temperature sensor, it is case sensitive, simulated. I have a real problem typing the word temperature. So these are the messages that are being sent out. So in the old scenario, this was just being piped directly into that fan control mechanism, but this is now going into the IoT, into the machine learning module, right? So if I go here and I just start looking at my machine learning module, so you can see here prediction is 0, so this is the message that came in, prediction is 0. I can keep doing this and hopefully we'll get one that says 1 at some point. Still saying 0. But what I can also do is I can look at that fan control module, just the last one. I have about 3 minutes left, I think. I did start a little bit late. So you can see it's coming in. So we have anomaly false, so you can see it's in an array with a string, so that's why you have to essentially unwrap that. So it's coming in saying false, fan turned off, true, fan turned on. So we're responding to the prediction that's coming out of that model that we built in the cloud and pushed down to the device. So that seems to have worked. So that's a minor miracle. So just to wrap up, this value chain applies everywhere, right? So whether your action is about decision support, hey, Mr. Operator, you need to do this because we don't trust the data enough to automate processes, or whether your action is to automate processes, then this applies as well at the edge as it does in the cloud. The key thing about action, if your action is based on data, you have to trust the data. If you don't trust the data, don't trust the action, right? So, get your subject matter experts involved and make sure that the thing that you're simulating is working the way you want to. And then just to touch on Azure IoT Edge again, these are the things it does. It's all very, very key that it does that, of course. I think we've talked about most of them. I think for me, the big ones are the code symmetry. You don't have to relearn stuff. And the fact that it's pretty simple to actually just push these modules, create these modules, and push these modules back down. And with that, I shall say thank you. Questions?
Thank you, Martin.